So my topic this morning is understanding climate change and its impact on Africa. I, I want to do that this morning by starting off. I know that most of us probably have some understanding of climate change, but just to make sure that we are all on the same point, I want to ask the question, what is climate? What factors affect climate change? Why is climate important? I want to ask the question, is the climate changing? Is it actually changing? And how do we know that the climate is changing? How do we explain that change? What does it mean for Africa? And then what can we do? So the first question, what is climate? And the first question I would ask is, if we are in Cape Town and we know that we normally have cold winters, cold, wet winters, hot, dry summers, and suddenly you had a cold and wet day in summer, does that mean that the climate is changing? I'm making that a question. If someone would like to answer, does that mean that the climate is changing?
No.
Okay, that's a good answer, thank you. So it's important to distinguish between what is weather and what is climate. What we experience on a daily basis is what we call weather. So when we look, when we check our apps on our phones, or we watch the news at night, what we see is the weather report, not the climate report. Weather is quite specific. So if you're in Cape Town, you'll know you can drive on the M3. You'll have the sun shining in Cape Town. It's raining in Newlands. It's windy in Wynberg. And it's cloudy by the time you get to Muizenberg, all on one stretch of road. That's just the way that the weather works. So weather is short-term, it's location-specific, and it describes the climatic condition at that point, at that particular time. When we speak about climate, we speak about long-term trends, usually plus minus 30-year trends. And we don't speak about the climate in a particular place, although we could speak about subclimates, but that's something different. Usually when we speak about climate, we'll speak about the climate in a region, and not just the climate in a particular place. When we speak about climate, we are interested in the rainfall, in the temperature, and in the winds in that particular region. I put down a Copenhagen map that shows the different climatic zones or climatic regions on the African continent. And you can see that across Africa, we have various different climates. If we go down to Southern Africa, we'll see around Southern Africa and South Africa in particular, we have a number of different colors as the climate changes in different places. So what affects the climate, and how is it that we get to this point where the climate down here in Southern Africa looks as diverse as it does? So some of the factors that affect the climate is latitude. So I've put down a little map on the side that shows, if we look at the Earth as a circle, we know that we have hot areas near the equator in the tropical zones. Then we have temperate zones where most of the people live. And then we have cold areas at the poles. So your latitude and where you are based on the planet affects your climate. Then another one is elevation. How far are you above sea level? Are you at sea level? Or is the particular area on top of a mountain? We know that the weather in the area also affects the climate. And then very importantly for us here in Southern Africa is ocean currents. So I've put here at the bottom just a reminder of the ocean currents. So we have on our side here in Cape Town, we have the cold water coming up from the Arctic and going up to the equator. And on the other side, on the eastern side of the country, we have warm water coming down from the equator towards the Arctic and circulating in the other way. And so Cape Town's cold, wintry weather is driven by this cold current, and the hot, dry weather on the East Coast is affected by this hot current coming down from the equator. Another thing that affects the climate is the topography of the area, and then of course vegetation. And vegetation is a big thing for us at the moment. If we think about, for example, deforestation, if we are cutting down all the forests around the world, what does that mean for the climate? But why is climate important? Why are we even talking about this big thing of climate change? Climate is important because if we are in agriculture, if you know when it rains, if you know when the sun shines, if you know when the wind will blow, if you know how much rain you get, you have an idea of what you are able to plant successfully. You'll know when to plant, you'll know where to plant, and that has a big impact on issues of food security. And we'll know when we speak later about climate change and its impact. One of the big impacts of climate change is what it will mean for food security on the continent. Climate is also important if we're thinking about where to settle. Where is it safe for people to live? If you have a place where wind speeds are high, if we have a place where it rains and it storms every year, it floods every year, if we have a place where it's cold and dark for most of the year, it's probably not a good place for human settlement. Also, if you're living in Cape Town, you know, in certain places, our wind speeds are particularly high. When you are putting up a building, we have to accommodate for those wind speeds. So, and another thing is climate is important for biodiversity. If we are introducing new plants or new animals into an area, we need to know whether those plants and animals will be able to survive and how they are able to live together in an ecosystem. So, how do we know that the climate is changing? One of the most important ways that we know that the climate is changing is because the glaciers are melting at the poles. So I showed earlier on the diagram of the Earth how the poles are cold. And what we are seeing on this map on the side is how over time the oceans are becoming warmer and the glaciers at the poles are melting. On average, there's been an increase of sea level of about 7 inches over the last 100 years. Now that doesn't sound like a lot, but if we talk about flooding and you're already living right on the edge of a floodplain, 7 inches of increase in the flood can mean the difference between your house still standing and your house being washed away. 7 inches can be the difference between life and death. Can be the difference between being able to stand in the storm and you being washed away. We'll also see on the next map that we're having far more frequent extreme weather events. And I'm putting in brackets disasters and not calling it natural disasters because not all natural events are disasters. We know in the Western Cape, We have a fire regime that means roughly every 12 to 15 years, we are meant to have a big fire that goes through the area. Those big fires in and of themselves are not disasters, but if we are allowing people to build low-cost housing, for example, in those areas, it becomes a disaster like we have in Hout Bay, where we have low-cost housing, we have informal areas in those high fire risk areas. Every 12 to 15 years, we have a major disaster in the Cape where people are living in areas that are high fire risk. In winter, we have people on the Cape Flats living in areas where we know they are prone to flooding in winter. And as climate change increases, the number of extreme events and the severity of those events, it becomes a problem for health, for human health. It also becomes a problem for human settlements, and it becomes a problem for livelihoods. And then the last one, as I've shown here, we know that the climate is changing because of the warming of the oceans. So the big question, what causes climate change? If you've been following the elections in the US, as I have done from time to time, we'll know that there is quite a debate about what causes climate change. We have one school of thought that says climate change is human induced, or sometimes we still use the term man-made climate change. Climate change is caused by human activity. And then there's another school of thought that says the climate is changing because of certain natural events. What's not in dispute in either of these two camps is that the climate is changing. What is being disputed is what is driving the change, or what is the cause of the change. But neither of these two schools of thought are arguing whether or not there's evidence of climate change, but rather what is the cause of the changing climate. So if we look at the first school of thought, that says that climate change is induced by human activity, one of the main things that we argue in this school of thought is that the use of fossil fuels for energy has increased the level of carbon dioxide in the atmosphere. Carbon dioxide, we know, is a greenhouse gas. And the role of greenhouse gases in the atmosphere is to allow heat and radiation to enter from the sun, and some of that heat to bounce off the Earth's surface and to exit again. If we increase the level of greenhouse gases in the atmosphere, it means that heat is entering through the atmosphere, but then is unable to exit. And so by definition, maybe if you think about if you're cooking, you can have your stove on a particular level, but then if you put the lid on your pot, the heat inside the pot increases even though the heat from the bottom hasn't changed. Increasing greenhouse gases is like putting the lid on the pot. The heat that comes from the sun hasn't changed, but because the lid is on the pot, because the greenhouse gases have increased, the temperature of the earth is increased because we have less heat being able to leave. The primary greenhouse gases in the atmosphere are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. And what we can see on this, for anyone who has watched An Inconvenient Truth, you may have seen this diagram before. And what it shows is how over millennia, the level of carbon dioxide in the atmosphere has never really gone over 300 parts per million. But currently we are sitting at well over 400 parts per million. And the level of carbon dioxide in the atmosphere is one of the things that we can then attribute to why the climate is changing and why global temperatures have gone up. So as I've explained just briefly about the sun's radiation coming in through the atmosphere, greenhouse gases allowing that to do so. We have radiation being able to leave, and that's a way that the Earth regulates its temperature. If we have on the other side more greenhouse gases, we have the same level of radiation still coming in, but we have less heat being allowed to leave, and that then comes back down to the Earth and heats the Earth a second time. That then causes the increased average temperatures. So on the other side of the debate, we have this question of natural climate change, whether climate change is natural. And some of the natural phenomena that they argue is that they say that there are certain solar cycles that has to do with the sun and how the sun increases over time. The sun becomes hotter and the sun becomes cooler. And so there's nothing that we can do. It just happens to be that the issue is that the sun is hotter at the moment. And so there's more radiation coming through. We also have the theory of volcanic sulfur, that because we've had more volcanic activity, that there's more sulfur that has gone into the atmosphere. And so again, it's a natural thing. We have more volcanoes, and the increased sulfur in the atmosphere has increased the temperatures. Then there's another theory that says that these are just short-term natural climate fluctuations, that over time the climate fluctuates naturally, and we are just in a cycle of high temperatures, but eventually that will come down again. Then we have what's called orbital wobbles. So it says that as the Earth orbits, it isn't exactly smooth, and that there are just certain places where as the Earth moves, it's a little bit higher than at others. There's also a theory of plate tectonics, that as the Earth moves again, with the moving of the plates, that is causing an increase. There's another theory that says that we've had an increase in the number of asteroids that has hit the Earth, and that has caused the increase. And then the last one is that there's an increase in igneous provinces, or increase of new islands being created, and that coming up from the Earth's core is what's heating the oceans. So we've got these two schools of thought. What do we do with them? What do we do with these two sets of scientists who say, on the one hand, the climate is changing because of human activity, and on the other hand, the climate is changing because of natural events? We have something called the IPCC, the Intergovernmental Panel on Climate Change. It's made up of scientists from around the world, from across disciplines, from across continents, and who speak with different voices. And they prepare reports for the United Nations on a regular basis. And the IPCC in 2007 said that most of the observed increase in global average temperature since the mid-20th century is due to anthropogenic greenhouse gas concentrations. And again in 2013, they said it is extremely likely that more than half of the observed increase in global average Surface temperature from 1951 to 2010 was caused by anthropogenic increase in greenhouse gases or human-induced activities, human activities, and that has increased the level of greenhouse gases in the atmosphere. In other words, even though there are two schools of thought when it comes to climate change, actually there's a there's a much louder voice that says that climate change is caused by human activity. There's far more scientific evidence to argue that climate change is caused by human activity than there is to say that climate change is natural. Climate change is caused by a natural event. So if we're looking at the African continent, what might the impact of climate change be on Africa? I've put down just some maps to show one aspect, which is rainfall. If we look at, although the numbers might not be very clear on your side, so we've got the 1950s, the 1970s, the 1980s, 90s, and by the 2000s. If you just look at the color, you can see how wet the middle of the continent is. We've got drier areas down the bottom and some drier areas up in the Sahara in the 50s. By the time we get to the 90s, what used to be dry is now red. What used to be quite wet is now red. And there's a lot less rainfall. By the time we get to the 2000s, we can see how dry the continent has become and how the rainfall has decreased. This is from a report by the CSIR. And what that means, just by looking at rainfall, increase in droughts. When we do eventually have rain, because the surface of the earth is hard, we then have increase in flooding. Because of the decrease in rainfall and because the surface is hard, because the soils are hard, we have decrease in food production. We also have a decrease in water availability. Low-lying areas are being decimated, or low-lying areas are being destroyed. And as you can imagine, we have changes in land use. So areas that previously were available for crop production can no longer be used for that. Areas that used to be riverbeds are no longer riverbeds. And so land use practices are changing. And because of that, we are also seeing increased migration across the continent. Here's just a map of extreme natural events in Southern Africa from 1980 to 2016. And what I wanted to show here is firstly how we've had an increase of events. And here we can see we have droughts. We have another color for floods. We have a color for storms. And we have a color for wildfires. Without going too much into the details of each of them, but just to see the shape and how extreme natural events have increased over time from the early 1980s as we get into the 2000s, how the extreme events have increased over Southern Africa. I know you've discussed this before, but I thought I would just include this in my questions, and maybe we can reflect some more on some of this next week when we talk about putting liturgy together. If human-induced climate change is correct, then have we become the creator? What does that mean for our relationship with God? Who is creator and who is created? Another question we need to reflect on, and something we are asked quite often: should we really be worried about the earth and what happens to the earth? Shouldn't we as Christians just be focused on getting to heaven? Won't the earth just burn up anyway at the second coming of Christ? Should we really be worried about the earth? And then that question we hear so often: will a good God actually allow all of this to happen? Going to park that there and not answer those questions now, and maybe see in our conversations, in our group discussions, whether some of that can come up. And then also next week, how we might introduce that as we speak about liturgy and putting liturgies together. So what can we do about climate change? One of the most important things we can do is advocacy. If we accept that climate change is human induced, then much of what we need to talk about is energy policy and how our mix of energy and energy sources is put together. We have to think very carefully about how we transition from a world that is dependent on fossil fuels to a world that becomes more reliant on renewable energy, because we know that fossil fuel is driving the increase in carbon dioxide in the atmosphere. We have to talk about, and I guess now with coronavirus, it has addressed that particular issue for us, but how do we reduce travel around the world so that we reduce fuel consumption, and in that way also reduce the amount of fossil fuel being used? If we think about where our food comes from, where our clothes come from, some of the products that we use at home, if we are buying things that have to be carted around the world, how do they get here? They get here in ships, they get here on planes. If we buy things local, it means that we can reduce the amount of energy that is used to get products to us. Another important thing that we can do is to think about how we reduce waste, and the impact that that has. And of course, what we have to, and as much as we keep talking about climate change and how we can limit the impact of climate change, we also have to begin to say that the climate is changing, and how do we adapt to a changing environment? So how do we adapt to a world with more extreme natural events? How do we adapt to a world with increased um, viruses moving around the world? How do we adapt to a world where coronavirus and other viruses like this um, become the norm? How do we begin to adapt to a world like that? So as we conclude, just some questions for us to discuss in the group.